we're again looking at the escape hatches specifically from the React docs, the learn section, as a way to understand now how React works behind the scenes, being able to describe that in the most concise and precise way, as a way to have clarity, not only to communicate that to your team members, your colleagues, and non-tech savvy people, business people, PMs, users, shareholders, but also when it comes to actually develop some features or UI, and when you need to escape the hatches or step outside of React, you know what are you doing and how you do that. So this is one of the reasons why I'm actually I took this course from Steve Keeney, head front-end engineer at Temporal. This durable open source. Oh my God! Give me a second here. Yeah, give me a second, quickly, because I'll need to. I need to put my brackets on. I need to put my brackets on. Where in the F is this? Come on. Where are they? Oh, in the bedroom. I'll be right back. And here we are. All right, finally. Sorry for the wait. So yeah, Steve Keeney, he is the head front-end engineer at Temporal, this open source durable execution platform that allow you to cover some sort of the business use case somewhat similar to Kubernetes, but again to cover more specific and in-demand business use case. So for example, companies like Versal is actually using that. And the reason of this course is to look at how you can now write React components in the most performant way, therefore React applications. And for that, one of the goal of this series of videos is that we are going to improve our technical communication along the hard skills and practical side. We're gonna get our hands dirty, as well as to look at the core structures, which is the introduction, React rendering, reduction rendering, context and suspense, as a way to understand now how React works behind the scenes. And if you're going to provide this service, which is in my case, yes I do that in the most precise and concise way, because especially when someone hires you, they want to know that you are the right people, so you can deliver outcomes quickly. So here in this introduction is more talking about what is the performance, or what is the value proposition of performance from the context of React, which is something you can apply also to your life, which is it is much more faster to not doing stuff than doing it, and we talk about why. And there's some corollaries to that, right? So it is much more faster doing things later than doing it right now, which is something that now React Fiber, these reconciliation engines, allows to do, which is something that was developed in React 16, and now here in React 18 it allows to, for example, this do some enable concurrent rendering or rendering prioritization, as well as the ability to pause, start, and stop rendering. So because of that, we need to look at how React rendering works behind the scenes. And luckily for us, now since the React docs actually have this self-paced docs as a way to understand how do we get here and how this storytelling actually improves not only our understanding but also our communication of it. So React, after all, we're going to make a quick recap of all of this. I'm not going to dive deep into the weeds, not at all. I'm just going to focus now is on the synchronizing with effects, and you might not need an effect, as well as the life cycle. Here is what we're going to focus our attention. So React is a JavaScript framework that allows to describe UI. And UIs here is JavaScript function. We look at how can we import them, export them, how can we use a syntax called JSX as a way to connect JavaScript with the HTML. Also, how can we receive this data to these components through its inputs, through props, rendering conditional components, rendering a list of components, and how important it is for React to write your components in a pure way, pretty much like a mathematical function. You take an input, given the same input, you always get the same output. Why is this? Because now it allows you to run these components in any JavaScript environment. So for example, in the server, so you can have now these components that passing is data to this component as props. You'll always return is that component, and you can serve that to millions of users, if that's the case, dozens of millions of users. And the other is that it allows us to catching, so we can avoid recomputing some components and therefore reducing our costs by using these built-in tools that React provides us. Use Mimo, use callback. And the other is that we can safely stop the execution of our rendering, okay, and then start that again. As for example, when we're passing down data to all of these components, and the way now you can see or React see these components is in a tree data structure, which is a computer concept from the computer science. It's a data structure, it's a way to organize our data. Okay, we got the render tree and the tree of dependency, where here the first is the way of how, once you understand the render tree, you can understand how the data flow through that, as well as any performance bottleneck. And from the tree render or the tree dependencies, how you can now is pass reusable logic to your components, and when it comes to serve that to the client, do that in the most efficient and effective way by only loading the necessary code needed. Okay, so you want to avoid any bloated code to send to the client, especially in poor call coverage area or low connectivity areas, 2G mobile internet. So then, because now we look at how can we write our components, after all, if we don't add any interactivity, this is pretty much like writing HTML. So we look at how can we add that interactivity by passing as a function to our event handlers in our HTML tag using the curly braces, okay? And then how we can is now show data to the components, pretty much like you want to show is the balance account in an application. So when you send some data, you actually see that data updated. So states is now the components memory, and that's what allows is to show data and then update the data. So the way how do we do that is inside of the event handlers. Okay, there are other places that you can do that, but for this particular case, this is when you're going to define your state updates. And when you do that, what happens is that React passes through a rendering mechanism, which is made of three phases: the trigger, the render, and the commit. So the trigger detect, hey, when this state update happened, it was at the root event, at the root of the tree, or it was caused, or as they like to, or as they call it, initial render, or it was caused by a component or any of its ancestors that state updates. So in the rendering phase, if this was caused by a initial rendering, what it's going to do is create all of these elements, React, okay, using the React.create elements. If it's not, if it's caused by a re-render, then it's going to now call the component that caused that state to call the component that triggered that state updates and compute all of its props, event handling, states, store that to use that in the later phase. And the output of that component, if that contains more components, it will call those components. And if the output of that contains more component, it will do that in a recursive way until there is no more component. So in this phase is when the VDOM is recreated, okay? And the VDOM is just this ideal representation of the UI that is kept in memory and sync with the real DOM. And this process is known as the reconciliation. So the React API provides us this a declarative way of describing our UI. In other words, you tell React what is the UI state what is the state that your UI want to be, and React match that state with the DOM. So because this process is also involved in adding some information known as fiber, adding some information to those DOM or to those elements in the VDOM. This process of reconciliation now has its own engine called React Fiber. And this React Fiber, which is this reconciliation engine, as a way to now, instead of you having to manually update the attributes or manipulate the DOMs or the event handler, that is taken care for you. And now, since React 16, it unlocks some of these features like concurrent rendering, rendering prioritization, and the ability to pause and stop or start a rendering. So, but the idea here is that on the commit phase, that's what happened. Okay. On the rendering phase, that's what happened. And then on the commit phase, okay, is when now the React will apply those changes to the DOM. So if this was caused as the initial rendering, what it's going to do is to take all of these elements that it creates in the previous step and then append that so you can see your UI. However, if this was caused by a re-rendering, then it will now apply only it will go through the reconciliation phase, which applies only the necessary DOM update as long as there are differences between renderings. So when that happens, the browser detects those DOM updates, okay, and then paint your UI. So this particular process is important to understand that, because this is what this is where the power of React and other frameworks that actually make use of the VDOM provide to the developers as a way to now create this UI. So we also look at how can we think of our state and every rendering. So state act as a snapshot on every rendering, and Yeah, and that means that when you're going to update your state, the value will be available in the next render. So the state value updates is in the next render, and inside of your event handlers, you can think that React fix that state value within the render. We also look at how can we now queue a series of state updates as a way to now provide several orders to the waiter, okay, and also to work with the previous state inside of that event handler, which is something that is quite convenient and useful, especially if you want to work with async operations in there. So in any case, then we look at how can we updating our objects and arrays inside of our states. Okay, the TLDR is that always return a new state. Use a function that allows you to return a new state, especially with arrays. Okay, so we also look at how can we create a new array. Always provide a new array to the state, as well as how you can now insert elements at the beginning or at the top, pretty much like in a stack or a queue. Also, how you can now add elements at a specific position in that array. How you can now is to remove elements in there by using filter. And when you say, hey, I want you to now get me all of these elements whose ID is not this. And then how you can now make your state update logic consist using Imer. So Imer make you to make your code update logic syntax mutable, something that we're quite familiar with. And then when you want to scale now your UI, how it's important to think in terms of how you're going to organize your state, how you're going to keep your state update logic, and also how you need to pass down data to different components. So first thing first is to understand how to think your UI state or your UI change as UI state or a UI change. So this is now the way of how you can define all of your UI in a declarative way rather than an imperative, okay? And the TLDR is that first, identify all the different visual states, determine what triggered those state updates, okay? As well as represent those states in memory using a state, avoid any non-essential states, and then connect your event handlers to set the state updates. So with this particular approach, which is part of the mental model of how now React is given to us as a way to, instead of thinking in an imperative way of how you're going to manipulate each one of those elements, all right, whether the attributes or the event handlers or the DOM manipulation. So React is now taking care that for you, so you can focus on building is UI. And not only that, you can also focus is on how you're going to organize those states and how those states are going to be interact with each other. That's what we have is the state structure as a way to say, hey, in your components, well, define is your React. You define your state, so group state related next or group related state. Avoid any contradictory state, any redundant state. If you can get this data from it is props or from another state, do that. Avoid redundant duplicate state, which means that it's very hard to keep them in sync. That's one of the reasons for that. And the other is the avoid objects deeply nested in your state, because updating that can become quite hard to keep up. So not only that, but when it comes now to share that state across all of the different components, because so far we have looked at how you can define your state in a component, but what happens when you need to define that state to share across other components? Okay. Oh, now is when each unique piece of state that you define, you will choose whose component is responsible for. And that lead us is to thinking in React, which is part of the section here. When they say, hey, you need first is the data and the mock, all right? And from that, once you get that, you're going to create that component. You're going to create is the UI component hierarchy. Then you're going to create is a static React component of that React static UI. Okay. Then define the minimal UI state, the minimal but complete representation of your UI, which means that, hey, how do you know about that? Well, if this data is frequently, if this data doesn't change too often, that's probably not in a state. If this data can be if you can get this data from its props or from another state, that's definitely not an state. If you get your data from props, usually that's not an state. So everything else remains. Everything else might be everything else might be a candidate for that. Okay, hey, does it remain unchanged over time? You know, this information, does it remain unchanged over time? That's not an state. Can you get this data from its props or from its can you get this data from its props or from its or can you compute that data from its props or from its states? That's definitely not a state. Are you getting this data from its props? That's not a state. Everything else is probably is an state. So once you look at how you can identify your state in your components, now it is time to identify where that state should live. Okay, and once you do that, which is part of the sharing state across different components, so once you do that, now we're going to add we need to add this inverse data flow. In other words, is that in the child components, we're going to receive this state and the event handlers, and it's in there that is going to emit that data, or is going to now update the state and notify that to the parent, right? So that's quite interesting, because this is now the way of how you can think in React, and especially as you're going to create now more and more ambitious UI, it is important to think in terms of when it comes to design and what capability this component will have, to mention about in terms of control and non-control component. So uncontrolled component is that information that this component will be managed using states, something as I mentioned here, like so. You know, control and uncontrolled components. So when writing a component, consider which information it should be controlled via props and which information should be uncontrolled the state. But you can always change your mind in later to refactors. So in practice, control and control are restricted terms. They're just usually used as a way of the capabilities and how you are designing this component. So in contrast, you might say a component is controlled when the important information is driven by its props. An uncontrolled component is when the important information it is driven by its state. But again, this is just to mention that when you do that, you need to define so when you define your unique piece of data, unique piece of state, you'll choose which components owns that. And that component will be is a source of truth to any components that needs that state. That's what we have, for example, applications like Redux and that kind of thing. Especially Redux, MOPS. It's a way to organize that state level data. And also how now React, especially when it comes to identify your state, how behind the scenes exactly. So when you give your component a state, you may think that state lives inside of the component, but the state is actually held inside of React. So React associate each piece of a state holding with the correct component that sits in the render tree. And that's why, because of this association that React now, because of the association between the React state to the render tree position, we can have now things that are helping us, for example, to preserve the state across components or set the state for that. So by default, if you have the same component at the same, if you have same components at the same position in the render tree, React will preserve that state. If you have different components at the same position in the render tree, React will reset that state. If he wants to reset is the state of the same component at the same position in the tree, you or show that show the component in a different render position, okay, or you just apply a key, which is a way of how you can indicate to React, hey, this is a unique component. This is something that I want you to keep track of this. And how, for example, when you're going to when you want is to order, or you want to actually make this component unique, especially if you're going to reorder or shuffle that like that, it is useful to use the data from the identifier from the data that usually must come from the backend, rather than the index. But in any case, that's some sort of performance optimizations. And then as you now react to more as the state react to more and more inputs, it is useful to think, or in this case, as your state react to more and more inputs, whether it's computer and human inputs, okay, it makes much more sense to use a reducer as a way to make your state management or to state update logic consist. So this is this reducer is just a function that takes a reducer function, which is just a function that takes a state and an action to generate a new bit of a state, all right? And then how we can now, as a second argument, by using this hook called use reducer, how you can now pass the initial state. It will give you now the state as an array, the state and the dispatch function, where you can now use that in your event handlers when you and provide an object with the type from that particular UI interaction. So all of the things is something that is, for example, if you are now handling is a chat application, okay, and then you want to react to, or this input is reacting to the chat message, or yeah, is this input reacting to the chat message, or you're sending is a message, or you want to reset the state inside of that message. This actually makes much more convenient to use that. And also we look at how can we pass down data to different components as a way to use context, because it solves a particular problem known as props drilling, when you pass down data to all of these children until the specific child that it needs to. If you, for example, hide or remove that React component from the render tree, then you break the link, and that causes a lot of problem, a lot of problem. So to prevent that, we have context. Usually context wasn't that good, but now has improved. So we use now context as a way to store is this data can be static or state that is going to make aware of its surrounding, which means it's going to make aware to the subtree component about that data. So the way you can do that is by creating a context and then use that context using the use context hooks in the specific component, and then provide that context with the value needed. It might be tempting to overuse context, but context from the React docs, it is useful for a small piece of data, or from small app level states. For example, theming. You want your entire React component or your entire render tree component aware of its surroundings. So you update that thing properly. Or also, you want it, for example, for authentication or analytics, where you want to actually is now pass down that data there. Another good example is React Router, which is using behind the scenes is context. You can take a look at their code. You can see the using is now context as a way to keep track which URL now the user is currently at. And when it comes now to manage much more or to react to several inputs in a particular state, how now it makes much more sense to use is reducers and context as a way to scale the state management in your application. So by creating a context that holds the state in a file, in a JavaScript file or a TypeScript file, by creating a context that holds the state and another context that create the dispatch function, we're going to hold that data like this. Okay. When you create that context, and then right after that you create is now the reducer functions, and when it comes to export that function to provide now the context from the state and the context from the dispatch, you use the use reducer that is gonna give you this the state and the dispatch, and that's what you're gonna use as their value in the provider, followed by the children's that you want to pass through. So the idea here is that when this particular state change, or when the value change in each one of those providers, now React will re-render all of its children that use that specific context, and starting from the provider, that value change. And this might be quite a problem, because this rendering is triggering every time that the value in the provider change. That's why we have, for example, some optimization techniques like, well, use MIMO, for example, as a way to catch the computation across the render, or callback as a way to catch the function reference across re-rendering. And that's something interesting. That's very, very powerful, very, very, very interesting. And yeah, this is an optimization technique that you can apply to your context as a way to save that. So anytime now the component is called, so it's going to now catch that computation using MIMO, or that function reference using callbacks, and only update that when you specify that dependency of array. So then we look at how can you now create your UI components that are able to escape the hatches, or the step outside of this, right? To get out of this. Why? Or what is this? Because sometimes your React components need to communicate, sync, and control external systems, whether it is to focus the input on a browser API, or to a video tag to play or pause that, or perhaps you want to connect to a server and start listening to message. So here React provides, for example, a way to remember things between re-rendering without trigger rendering using useRef. And the use case of this is that for timeout ID, you are interacting with the web APIs here, with an external system, as a way to hold as a reference and prevent any memory leaks. Timeout ID, so manipulating DOM elements as well, and also is any object that you don't need to compute or calculate between renderings. So the first case is something that we look at, how can we create now, for example, timers, or how much time has passed, something that I know how to do that. And the other is now how the use ref fits into the rendering mechanism. Well, because React now define the use ref hooks, which is, and after all, is a JavaScript object that has the current. It defined that before the commit phase, and then update that or set the value after the commit phase. And when it comes now to manipulate DOM elements, for example, for scrolling, or for focusing an input, or to interact with an HTML DOM, we can do that by using this ref as a way to get that. For example, like this, okay. And one of the things to avoid that, okay, as a way to say, hey, if you stick to use ref for this specific case, like focusing an input, or scrolling, or using the timeout ID, you will be safe. If you find yourself needing to go other use case, that might be complicated unnecessarily your logic, and therefore your application can be in an unpredictable state, which is something that you don't want. That's why, for example, when we talk about these escape hatches, you rarely, or you usually, or most of your application logic and data flow should not rely on this feature. So, the other is that what happens when we need, for example, is to synchronize with external systems, for example, like connecting to a server, or send analytics to a log, or send analytic logs when a components appear on the screen. So for what happens when you want to now interact with what happens when you need to interact is with non-reactive components or widgets. When you want to connect to a database or a server, or send analytics, send an analytic log when your user or when the component appear on the screen. So here, because React say, I just want to split the things up here a little bit. We have your effect and you have events. And this distinction is something important because when you're writing your components, you have two types of logic. You have the rendering logic, and then you have is the event handlers logic. So your rendering logic must be pure. Your event handler is when you can perform these side effects. Side effects are so side effects change the behavior of your program that is not intended for its primary purpose. In other words, this function is actually mutating as the global variables, or changing the data structure, or performing input and output operations. So for example, in our case, when we want to connect to our server, okay, which is not pure calculation, you have to wait for that, okay, and that can be in several states. So React say, well, if you want to perform these side effects, if you want to perform side effects, you will use this hook that will by default run that code by rendering itself. And this happens is after every commit phase. After the screen updates, React team decide to say this is a good place when you can now render this component, or when you can call this side effect, this piece of code, and by default, perhaps you might not need an effect, okay? Which is something important. If you're not connecting to an external system, you might not need an effect. If you're only adjusting an state based on another state, you might not need an effect. However, how you can define is an effect is by using the effect. And now this effect is and now this effect by default run after every commit when this component as caused by rendering itself. Most of the time you don't want to do that. That's what we pass is an array of dependency to this to identify or to tell to the hook, hey, I just only wants to run this side effect after this dependency change. And then you have is the cleanup code, because after all, you're connecting to external system. You have this connect and disconnect, subscribe or not subscribe. So here we look at the anatomy of the use effect and the life cycle of the use effect. So then the anatomy of the use effect is that first it receives the setup code, and inside of the setup code you also have is the cleanup code, and the second argument is the second argument it is the dependency array, which means is that which means is that I'm going to once this dependency changes, I'm going to run this. And the life cycle of this works like this component or this code will run when the component is mounted or appear on the screen. So the setup code will run first. And when this component re-rendered, React will call as the cleanup code with the all previous states and data, and then run the setup code as long as the dependency change, right? If the array is empty, it's only going to run when the component is mounted. And the cleanup function will run one last time when the components are mounted, when disappear from the render tree. So with that, now we look at what is the and especially here in how to handle is effect firing, exactly how to handle effect firing twice in development, because in React 18 we have this strict mode where now allows us to prevent some common bugs and prevent some common bugs in our state and in our in our states or in our effects. So it rerun the component, it re-render the component twice, and it rerun your effect twice. And the idea here is that instead of actually see how you can get rid of this, is that how you can how you can make this side effect work with remounting. So in development, you will have now the code run like setup, cleanup, and setup, but in development you don't have that. So when you're writing your effects, this actually fall into and will fit into this common pattern. Or you connect to another React component, so for example a map, okay, and then you have to define is the cleanup. Sometimes when you connect into this, you don't need to. But if you're subscribing to an event, for example the scroll, you want to define your setup logic as well as your setup logic and your cleanup logic, okay? If you want now to trigger animations, again, your setup logic and cleanup logic. And now the most challenging part, which is fetching data. So you should either abort or ignore the result, because there is no way of undo a network operation. So the solution here that I come out with when React is saying, let's go to abort that or ignore that, which means is that we're going to define is an ignore flag in our setup code that is false, and if we need to rerun this side effect, and the cleanup code is going to now ignore that data, even though in development you will see to fetch in the network tab. And there is nothing wrong with that, with the approach about the first effect will immediately get cleaned up, so it is copied. The ignore variable will be set to true. So even though there is an extra request, it won't affect the state thanks to the if ignore check. Exactly, because now we are now calling this code twice. We're triggering this code twice. In production, there will be only one request. Remember that after all, development is actually setup, cleanup, setup, okay? But in production, there will only be one request. So you might thinking is that how can I improve the developer experience because of this particular case, since there is no undo in a request or network request. So you can now use some alternative uh, in as a way to fetch data, because what happened is that even though that you have to manually write your logic to even though you have to manually your logic to ignore the previous, especially in development, the previous uh, request, because as you can see in development it's passing through the setup, cleanup, setup function. Okay, so it has its own downside from this manual approach, because effects won't run on the server. So this means that in the initial server rendering will only include the loading state with no data. The client will have to download all the JavaScript and render your app to only discover that there is no, that now it needs to load the data, and this is not very efficient. And when they say that the effect don't run on your server, is that the way how now you're sending that data, when the server initially, when the, yeah, this means that the initial server rendering HTML, it only includes the load state with no data. The client needs to download that JavaScript only to know and only to discover that now it needs to load the data, and that might not be very efficient. The other is that it causes this network waterfalls. So your parent and the child and the other child component, if they're now triggering is this async operations, is they're now fetching data, you're actually making this network waterfall, which is which slow down your application. Also, you don't have the ability to catch the data, because when you unmount and remount your components, React will call that setup code again. So first, your code doesn't run on the server. It means that it means that the pre-render or the initial server rendering HTML is sent to the client. The client now have that will only include a loading state with no data. The client needs to actually fetch the JavaScript to render these components, only to discover that now it needs to perform the network request. That's not efficient. The other is that you can have this network cascade, which means that your parent, so the parent and the child and all of the other child components can have or can perform its network requests, okay, which will slow down your application. And also, you don't have the ability to catch data or fetch data, because when you mount and remount your when you unmount and remount your component, there is no way to store that data. Okay, so you now have to actually fetch the data again, and it's not very ergonomic, because it requires but again, this is just only the problems with this particular approach when it comes to fetch data. Again, using the side effects. So the effect is not running on the server. It's easy to create, is not duplicating requests, okay, or this network waterfall, and you don't have the ability to catch the data, because anytime you unmount and remount your component, you have to fetch the data again. That's why now React recommends to go with solutions like frameworks that actually has this built-in solution or data fetching mechanism. For example, Remix and Next.js, or going with this client-side catch or building your own. So for example, React Query use SWR and React Router 6.4. You can build your own solution, which now underneath the hood is going to use effect, but you need to add the logic to the duplicate request, catching response. You need to add the logic to, you need to add logic for deduplicating requests, especially because your effect is not running, your effects don't run on the server. Deduplicate requests, catch your response, and avoid network waterfall. Oh my God! Deduplicating requests, catching, which is not, it's not trivial, catching things. Deduplicating requests, catching, and deduplicating requests, catching, and avoid network waterfall. Oh my God. So data fetching as routing is something that is not trivial. So this is now fetching data, and what you can do here is a way to implement this manual step by step. Oh my God. And this is what 95% of your applications will rely. This is the logic of your 95% of this application. The other is ascending analytics. In development, log visit can be called twice every URL, for every URL. So you might be tempted to try to fix that. We recommend keeping this code as it is, like with earlier example. There is no user visible behavior difference, but what you can do is to now point to a different environment, especially when sending analytics. Hey, let's go to point to a different environment in the staging environments for that. So on production, there will be no duplicate visit logs. Okay. To debug the analytics event you're sending, you can deploy your app to a staging environment, which runs in production mode, or temporarily up to strict mode and is development only remount check. You may also send analytics from the route change event handler instead of effects. For more precise analytics, intersection observers can help track which components are in the viewport and how long they remain visible. Not an effect. Initializing an application and buying a product. So with that, now you might not need an effect. Is the ways that how you can now escape the hatch from React Paradigm. But sometimes it is easy to actually overuse effect, and they have a dedicated time for that. If there is no external system involved, for example, if you want to update a component state when some props or state change, you shouldn't need an effect. Removing unnecessary effect will make your code easy to follow. But again, here we are reading is that when you don't need an effect, how to remove unnecessary effect. You don't need an effect to transform data for rendering. You can easily use that for, you can use the existing data from that. You don't need an effect to handle user events. You do need effects to synchronize with external systems. For example, you can write an effect that keeps a jQuery widget synchronized with the React state. You can also fetch data with effect. For example, you can synchronize the search result with the current search query. Keep in mind that modern framework provide more efficient built-in data fetching mechanism that writing effects directly in your components. To help you gain the right intuition, let's look at some components concrete example. Updating a state based on props or state. This is more complicated than necessary. Exactly. So here we're gonna look at when you don't need an effect. Updating a state based on a proper state? No, don't do that. Compute that. Catching expensive calculations. You might be tempted to use an effect for that, but instead use memo for that, for example, or use callback for that. Catching expensive calculations. This tells React that you don't want to do the inner functions to rerun unless either the to-dos or filters have changed. And this is something interesting because it's like how to tell if a calculation is expensive. Console.time and console.time n. Perform the interaction you're measuring, for example, is trying to get the input there. The other is resetting all state when a prop change. Again, relies on the key for that and use the ID for this. Now it makes sense. Updating a state based on a prop state, that's not on a state. Use the props instead or compute that. Catching expensive calculations, no. Avoid redundant state and unnecessary effects. By actually using memo for that. Hey, I just want you to run this computation after this dependency changed. For example, here, after the to-do change, after whether it's a props or a state change, resetting all state when a prop change, use the key for that. Adjusting some state when a prop changed. Adjusting some state when a prop change. You can just compute that. Again, exactly, adjust some state when a prop change. It is better again, adjust some state when a prop change. It's better to calculate that. Sharing logic between event handlers. So for example, let's say you have a product page with two buttons, buy and checkout, that both let you buy that product. You want to show a notification whenever a user puts the product in the cart. Calling show notification in both. Button click handlers feels repetitive, so you might be tempted to place this logic in an effect. So avoid event-specific logic inside of an effect. Sharing logic between event handlers, like this. If product.is in cart, show notification. Oh, not at all. Avoid specific logic inside an effect. Compute that. No. It's like compute that. Exactly. Compute that. Use that in the, okay. No, use that in the compute that. If you need that. So event-specific logic is called from event handlers. Handle button click. Or you either compute. This effect is unnecessary. It will also most likely cause bugs. For example, let's say your app remembers the shopping cart between the page reload. If you add a product to the cart once and refresh the page, the notification will appear again. It will keep appearing every time you refresh that product page. This is because product that is in cart will be true on the page load. So the effect above will call show notification. When you're not sure whether some code should be in an effect or in an event handler, ask yourself why this code needs to run. That's another good question. And once you know that, what do you want to do? Oh, no. Use effect only for code that should run because the component was displayed to the user. So in this case, it's like when this code needs to run. You say byproduct. Okay. Event-specific logic is called from event handlers. Sending a post request. This is quite something that, yeah. So sharing logic between an event handlers. So create is a base function to share that logic between handlers. Sending a post request, again, don't use an effect for that. In fact, putting into an event and the event handler like that. Sending a post request, change of computations. Sometimes you might feel tempted to change effects that adjust to a piece of a state based on another state. Again, no. Change of computation. Instead of actually doing this, so you have now effect that is going to run after every commit phase or after I specify that. You in fact, in this case, change of computation, you in fact would like to use is a callback or compute that. Let the logic be handling here. Calculate calculate what you can during rendering. Calculate all the next state in the event handlers. But it's like that. Don't use effects if you're not synchronized with another event. This is a lot more efficient also if you implement a way to view game history. Now you will be able to see each state variable to move from past without triggering the effect change that adjusts every other value. If you need to reuse logic between several event handlers, you can extract a function and call it from those handlers, which is part of the sharing logic between event handlers. Remember that inside event handlers, they behave like a snapshot. Remember that inside of the event handlers, a state behaves like a snapshot. So for example, here, inside of your event handler, a state act as an event, as a snapshot. So set the car here, set the gold car. So for example, after you call set round plus 1, the round variable will reflect the value at the time that the user clicked the button. If you need to use next value for calculation, define it manually like counts next. If you need to use the next value for calculation, define it manually like next round. In some case, you can calculate the next state directly in the event handler. For example, imagine a form with multiple drop-downs where the option of the next drop-down depend on the selected value on the previous drop-down. Then a change of effect is appropriate because you're synchronizing with network. If you're fetching the data. Initializing the application. Some logic should only run when the app loads. Exactly. Not at all. You might be tempted to place this in effect in the top level. But again, doing that during rendering. Especially if you're running this twice. However, you quickly discover that it ran twice in development. This can cause issue. For example, maybe it invalidated the authentication token because the function wasn't designed to be called twice. In general, your component should be resilient in being remounted. This includes, okay, if you need to call this, although it might not ever, but it is initializing the application. Some logic should only run once when the app loads. Although it may not ever get remounting in practice in production, following the same constraint in all components make it easy to move and reuse code. If some logic must run once per app load rather than once per component mount, at a top level, variable to track whether it has already executed. You can also run it during module initialization and before the app renders, which is this. Run only once per app loads. This is much better here because now your running is only once when the app is mounted. Code at the top level runs once when component is important, because otherwise, if for example you need to re-render the entire app, you're gonna run this code when this component is mounted, and this is something that you don't want. If you need to initialize your application, put the code here. Notifying parent components about state change. No, use an event handler for that, or update that. You're going to pass down that. Use an event handler for that. Good. Performs all update during the event that caused them. Exactly. If you want to notify a parent component about state change, do that in the event handling. In the event handler. Exactly. Do that in the event handler. With this approach, both toggle component and its parent component update their state during the event. React batches update from different components together, so there will only be one render pass. You might also be able to remove the state altogether exactly, and then receive that instead from that, which is exactly here. Hey, I received the state. Now I'm going to trigger is the onChange here, which is usually what you want. This is, for example, for small level application, for small level UI components. But for now, if you want to actually pass some state or some data, it's like this is lifting a state up. The parent component fully controls the toggle by toggling the parent's own state. This means that the parent will have to contain more logic, but there will be less state overall to worry about here. This is known as the component, notify parent component about state. No, lifting state up, which means that it's going to define as a parent, the state on the parent, and pass down the state and the event handler to the child component, known as inversion data flow. Passing data to parents. Passing data to parent. On fetch. Passing data to the parent. No, put that logic in there. Good. Passing data down to the child. Use an API. Exactly. It put the state there at the parent, and then you're gonna pass down. Passing data to the parent. Again, following is this one-way data flow. Subscribing to an external storage. Sometimes your component may need to subscribe to some data outside of the React state. This data could be the third party third party or building browser APIs. Since this data can change without React knowledge, you need to manually subscribe to your components to it. This is often done with an effect. If you need to manually subscribe to that, but instead, okay, here the components subscribe to an external data store, in this case the browser, Navigator Online API. Since this API does not exist on the server, exactly, so it can be used for the initial HTML. Initially, the state is set to true. Whenever the value whenever the value of that data store changes in the browser, the component updates its state. Although it is common to use effect for this, React has a purpose built-in hook for subscribing to an external store that is preferred instead. Delete the effect and replace it with call using external store. Subscribe, get a snapshot, and get server snapshot as a way to subscribe to external system or external store. Okay, subscribing to external store. Subscribing to a browser API. When possible, recommend use built-in React with use state and use reducer instead. The using external storage API is mostly useful if you need to integrate with existing non-React code. Extracting the logic to a custom hook. Again, if you want to save progress, because this is a hook. Subscribe and get snapshot. In Navigator, okay, this is if you want to this is if you want to subscribe to external systems. Subscribe and get snapshot. Subscribe and get snapshot. Okay. Okay. Adding support for server rendering. I'm getting an error. There's a lot of get snapshot should be catch. Do not return always different object from get snapshot. React will re-render a component if snapshot return value is different from the last one. This is why if you but it says if you want to synchronize with external stores or external system. Okay. If you want to synchronize with external store or external system, the other is fetching data. Many apps use effect to kick off data fetching. It is quite common to write a data fetching effect like this. Avoid fetching without a cleanup logic, because as we saw previously, how you can go into synchronize with effect and how when you write your effect will fit into one of these patterns connected to non-React widgets or to animations. Connected to non-React widgets, animations, data fetching, subscribing to exact, subscribing to events, animations, non-React components, data fetching, and how especially in data fetching, which is not a trivial thing, uh, how you need to always return is a cleanup logic, and how you can fit in development your effect to remount, to work after remounting. Mm-hmm. To fix race condition, you need to add a cleanup function. Because this will trigger its race conditions. And when you say race condition, is that, however, the code has a bug. Imagine you type hello fast, and then the query will change to H to hey. This will kick off a separate fetch, but there is no guarantee about which order the response will arrive. It's because you are guarantees this. You're preventing to fix race condition. This issue apply to any UI library, not just React. Solving them is not trivial, which is why modern frameworks provide more efficient built-in data fetching mechanisms that fetching data in effect. And then you're going to return that. It's because this is to prevent some race condition. Like ignore this. And once you get that data, done. Also, this alone won't be as effective as using a framework building data fetching mechanism. Moving the data fetching logic into a custom hub will make it easy to adopt an efficient data fetching strategy layer. Recap. If you can calculate something during rendering, you don't need an effect. To catch a specific calculation, use Mimo instead of use effect. To reset the state of an entire component tree, pass a different key to this. To reserve a particular bit of state in response to a props change, set it during rendering. To reset a particular bit of states in response to a prop change, set it during rendering. Code that runs because a component was displayed should be in effect. The rest should be in events. If you need to update the state of several components, it is better to do it during a single event. If you need to update the state, update the state of several components, it is better to do it in a single event. Or in other words, this is not a single source of truth. Whenever you try to synchronize state variables in different components, consider lifting state up. When you try to synchronize state variables in different components, you can fetch data with effect, but you need to implement cleanup to avoid race condition. That's one of the reasons why we implement is that cleanup logic in data fetching to prevent race conditions. And one of the trouble of that is that you have now to fix the deduplicate network requests, waterfall networks, and caching. Holy moly. Transform data without effects, and then the life cycle of the effect. How React resynchronize your effect? Thinking from the effect perspective, how React verified that your effect can resynchronize. Effect reacts to reactive variables. And then separating effect from event. Okay, so that was quite interesting. That was very, very interesting. That you might not need an effect. Okay. Okay, okay. Okay. Mm-hmm. Mm-hmm. Transform data without effect. So only active to do. So instead of doing this as a way to now when you need to run this, you define all of this effect here. And I know why this caused the most cognitive burden. Yeah. Okay. So that'll be all for this video. Take care. Bye bye.